functions in several variables, examples, and domain. Let's take some examples. Let's suppose that we have a rectangle with sides x and y, so x and y. So the area of this rectangle is given by the product of x times y. So we have here a function axy in two variables, x and y. X must be positive and y also. So the domain of this function, the condition is x positive and y positive. So xy, any point in the plane OXY where x is positive and y also positive. So the domain of the function would be this part without the x-axis and y-axis. So this is the domain of the function f. My function a, but without the y-axis and without the x-axis. Example number 2. The volume of the cylinder of a circular base of radius r and height h is given by the area of the base, the area of the circle is pi r power 2 times the volume will be the area times the altitude, the height h. Okay, so this is the function in two variables r and h. Also the same, r positive and h also positive. So the domain is the same as the previous one. The third example, if we take a rectangular box, so what is the meaning of rectangular box? So here, each side is a rectangle. Okay, if I suppose this length x, so I have a rectangle here with sides x and z, x, z, and also here I have, I suppose this length y here, so I have here also rectangle with sides x, y, y, x, and also up I have a rectangle with sides z, y, z, y. So what is the volume of this rectangular box? It's, the product of x, y, z. So this is a function in three variables. Domain of a function in two variables. Let's take some examples. The first example, the function f1 equal root y minus x. So here, the condition is this term must be positive. So y minus x is positive or equal to 0. So y greater or equal x. So the domain of the function f1 is the set of all real numbers, of all points in the plane where y greater or equal of 2x. So if we sketch the line y equal x, after that, the points where y greater or equal x will be all of the points here. Because if I take this point, for example, this point, the coordinate of this point, let's suppose it's x0, y1. So y is 1, x is 0, so y greater than x. So all of the points here satisfying this condition, that y greater or equal x. So here is the domain of the function f1. Here I have equal, so the line is included. Second example, here we have function f2 equal ln y minus x. So the condition here, y minus x must be positive and not 0. So y minus x greater than 0, so y greater than x. So the condition y greater than x. So this condition is satisfied here in this region. Okay. This is infinite region. Here we will go to infinity. Okay. Etc. And without the line. So this is the domain of my function f2 without this line. Because this line satisfying y equal x, I need y greater than x. Example, third example here, f3x equal 1 over 1 minus x. So here the condition that this term is not 0. So y minus x different from 0. So y different from x. So I will take the domain of the function f3 will be all of the plane are squared without the line. Without the line y equal x. So the domain will be all of the plane here and here, but without this line. This line is deleted. Next example, a function f4 equal root of 4 minus x2 minus y2. So the condition here is this term must be non-negative, so greater or equal 0. So if we write 4 minus x2 minus y2 greater or equal 0, this means 4 greater or equal x2 plus y2. So the domain of the function f4 is all of the points xy in the plane are squared where x2 plus y2 less or equal 4. So if we sketch the circle x2 plus y2 equal 2 power 2 or 4, so it will be the circle. So I need here the points inside the circle, okay? Because this term here, if I suppose the point m, xy, so this number here, x2, x power 2 plus y power 2, it's the length OM. So if the point M is here, so the length OM, O is the origin 0, 0, the length OM will be, this length will be x2, x power 2 plus y power 2 will be less or equal 2, not 4. Equal 4, is or equal 4, yes. So this length is x power 2 plus y power 2, it's the length OM power 2, okay? So length OM power 2 less or equal 4, so the length OM less or equal 2. Okay, so the domain of my function is inside the circle. This is the domain of my function inside the circle. Domain of the function f4. And because I have equal here, so I will take it with the circle. So circle is included. Because any point here, for example, this point with coordinates 2, 0, satisfying this condition. If I give x2, y0, it's correct. Root 4 minus 4, it exists. The answer is root 0, 0. Next example, function f5 equal ln x2 plus y4 minus 4. So here the condition that this term is positive, not 0, strictly bigger than 0. Okay, so the condition is x power 2 plus y power 2 minus 4 greater than 0. We can write it like this, x power 2 plus y power 2 greater than 4. So the region will be outside the circle. So this is the domain of my function. all the region outside the circle, and without the circle, because I have here bigger than 0, without equal. So the circle here is not included. So this circle is not included in the domain. Why? Because if I take this point x2, y0, if I give x2, y0, so I have 2 power 2 or minus 4, so I have ln 0 doesn't exist, it's not defined. ln is not defined at 0. So the domain of my function outside the circle, without the circle. The last example, the function f6 is given by root 4 minus x2 minus y power 2. And we solved this part before. What was the domain of this part? The domain of this part, it's inside the circle. If I call it day 1, so day 1 equal inside the circle. If I have the circle here, so it's inside the circle. And if I call the domain of this part here d2, also we calculated d2. What was d2? It was the part, if I call, suppose this is y equal x, so this is the part up of the line y equal x. With the line y equal x, because here y minus x. So I have two conditions. The condition from here, I have this condition, x power 2 plus y power 2 less or equal 4. And from here, from this one, I have this condition, and I need y minus x greater or equal 0, so y greater or equal x. So this part will give me d1 inside the circle, and this one will give me up of the line. So the domain of my function will be this part. So this part inside the circle and up of the line together. So it's the intersection. So my domain here, it's day1 intersection d2. So here I have equal, so it will be with the part of the circle here, this is included, and I have equal here, so it will be with the line. So the line is included here, line is included, and this part, the half of the circle, is also included. So this is the domain of my function f6.